Now, there are a few issues that came up with interpreting some of the data, and I think these are good questions to think about because it's not just about the statistics, it's about how the statistics relate to the design and how you use both those two things together to interpret results or to make decisions. All right, so we had the homework problem, I think it was in chapter 13 about the swimmers, and it was a one-way ANOVA. So it was a situation where you had three groups of swimmers, those that did 15 hours or less of practice, 15 to 25 or more than 25, the mean times of those groups, and turns out that it was not significant. All right, so I'm actually quoting Dan here because he raised a great point, or at least something that he raised a number of issues that I want to talk about. So he concluded from this that it does not matter how much time swimmers practice, right? And then here's the thing that he said that was that kind of provoked me. Of course, here any difference in time is meaningful, if not significant, because winning a race by 0.01 seconds still is winning. So I think people would agree with that, right? So you do this experiment, or you read about this experiment where these three different groups do not come out statistically significantly different, and you put yourself in the role of a coach. And as a coach, you're going to say, that's it. We don't have to worry about practice anymore, guys. I know you don't like it. I don't like it. Let's just forget about practice, or just do a little bit. It just doesn't matter. Well, first off, I would say that if that's that conclusion is not warranted by these results, because the conclusion shouldn't be it doesn't matter how much time swimmers practice. You have to go back to the original kind of setup of the design. This is not like any amount of time. This is between less than 15 hours and more than 25 hours. So a more accurate conclusion would be that there's no significant difference in swimming outcomes with 15 hours or less of practice, or 25 hours or more practice, or in between. And that actually might make a little more sense. As a coach, I might say, probably not, but I might say, you know what, 12 hours is enough. After that, we don't gain more, there's no more quality from that. In fact, maybe we're just going to get ourselves all tired out, start using poor technique, the practice becomes less meaningful and maybe even counterproductive at some point. But what it doesn't mean is that any amount is the same. Certainly 0 hours of practice would not be as good as 15 hours of practice. And probably 100 hours of practice would be too much because you just kill yourself, right? So it's more a question of these in-between stages, and this pretend study would say there is no difference. All right, the second thing I want to say is this 0.01 and this idea of how much is enough. Got to go remember that when you're doing this statistical significance, what you're testing is the null hypothesis, that there's zero difference. And if you fail to reject that, you're really saying that there's not even a 0.01. We can't detect a 0.01. So I don't know how you interpret that. But this statement here, I mean, really, if you believed in this study, you would say, well, it's not even 0.01. We can't reject the null hypothesis. We got to assume it's zero. All right, but the last point is, let's say that you have accepted the null hypothesis, it's zero. This study still would not lead me to believe as a coach that I don't want my players to practice 25 hours or more. Because I have to take into consideration other things that I know besides the study. The study is just one piece of evidence. All right, so the first thing I know is more practice is usually better, up to a point. And maybe I'm a swim coach for 30 years, and I know 25 hours is not that much practice, and we got to do it. So I got to take into account background knowledge, or in research, I would say the literature. One study can't override years of findings of other studies or a theoretical background. All right, but the second thing is to me there's a flaw in this design that would not lead me to make a decision based on it, and that is it's very likely that a finding like this is not because there is no difference in the number of hours, but that different players or different swimmers start with different abilities. It could be, in a study like this, that the very best swimmers are practicing less. Maybe they feel like, oh, they're the best on the team, they don't have to practice. And the struggling swimmers are practicing a lot more. So this wouldn't prove that more practice in hours of practice doesn't make everybody better. It just means of those people who are practicing more or less, there is no difference. I would really want to trust this more as a coach, a better design that would take into account the kind of a pre and a post measure, and then to see if that additional hours of practice makes a difference, if it helps swimmers get their times down better. So I guess my main point here is you got to be careful in how you interpret the results, and you also have to interpret the results in light of theoretical knowledge and with consideration of the quality of the study design in the first place. All right, so this brings up an issue from the last module. It's kind of the same kind of thing. It was a small part of the module talking about effect size and paired samples t-test, where you have pre and post, or two measures with the same participants. And I want to talk about effect size and those guidelines we got at the beginning of the semester. And again, the point here is going to be that context matters when thinking about effect size. All right, so I got three examples. The first is a paired samples t-test, where you're doing pre and post measure of student learning on knowledge of key battles of the Civil War. So an SLO in PDE language is a paired samples could be a paired samples t-test case. All right, so I know students do not know anything about the Civil War. I know nothing about the Civil War, so I would know for a fact that my pretest is going to get pretty close to zero knowledge evidence from the students. And if I spend 6 weeks teaching the basic battles of the Civil War, I'm going to have huge growth. I better have more than one standard deviation increase, or I've probably not been very successful. But if I have two other situations, let's say I'm looking at 50-meter swim time of novice swimmers, pre and post measure, I'm probably going to get quite a bit of growth, because some of them maybe can't even finish the 50 meters to start with. And they haven't learned some of the fundamental things that I could teach. And they haven't practiced much in the past. So they're all going to make, or most of them are going to make, significant improvements in time. And the last case is, let's say same thing, I've got 6 months to improve the swim times, but I'm working with college level athlete swimmers who've been swimming for almost 10, 15 years. And it's going to be hard to make the same kind of level of increase with those kind of athletes. So it's always a matter of context when you're looking at effect size in any kind of statistical comparison. But I think especially you have to really be considerate of the context when you're doing effect size for paired samples t-tests, or any kind of time you're looking at pre and post measures. Context is going to make a huge difference.